Okay, here's the last question from our applications lesson. A student that's 1.6 meters tall walks directly away from a lamppost at a rate of 1.2 meters per second. I know I'm going to need a diagram, so I'm going to go ahead and get that started. So this guy is 1.6 meters tall. There's my little guy. And he has walked away from a lamppost that is 20 meters away. The rate at which they're walking is 1.2 meters per second. The light on the lamppost is 8 meters above the ground. So there's my lamppost, and it's 8 meters tall. Determine the rate at which the student's shadow is lengthening when they are 20 meters away from the base of the lamppost. Okay, so a shadow is made, making this similar triangle, and there's the guy's shadow there. Okay, so we have a set of similar triangles, and we have some knowns and some unknowns. So I'm going to call this distance from the lamppost to the person y, and then the distance of the shadow x, or the length of the shadow x. And I'm going to write that down. Let x be the length of the shadow, y is the length, sorry, let's say distance to the lamp. Okay. And I also know, it's given in the question, that the rate that they're moving away from the lamp is 1.2 meters per second. And what I'm looking for, what I don't know, is the rate of change of the shadow. Okay, so let's think about what we know about similar triangles. So this is where I'm figuring out what formulas I want to know. I know that in a similar triangle, 1.8, this distance here, is related to this back distance here in the same way that x is related to x plus y. Okay, so there is a relationship between, this is my similar triangle relationship, so I need to understand that. And so I'm going to, sorry, that is 1.6. Okay, so I'm going to rearrange to solve. So I've got 1.6 times x plus y equals 8x. 1.6x plus 1.6y equals 8x. And 1.6y equals 8x minus 1.6x. 1.6y equals 6.4x, y equals 4x. So this is the relationship that I'm going to end up using. Okay, I'm going to take the derivative of this now. This is the rate that it's changing. The derivative of y with respect to time. So the derivative of y is just 1. I can write that in there if I want to. And the derivative of x with respect to time is just 4. Okay, and now I can plug in stuff. Here's my rate of change. So this is 1.2 meters per second. 4 times the derivative of x with respect to time is what I'm solving for. Now I can just rearrange to solve and see that the derivative of x, like the rate of change of the shadow length, is 1.2 divided by 4, or 0.3 meters per second. Okay, for homework. There is quite a lot. You need to do 1 through 6, then 7 through 12. So your goal for day 1 is 1 through 6, then 7 through 12, 14, and 16.